So for this, it says to factor by grouping. So I noticed that in this first term here, I can pull out in the first two terms, I can pull out a 25x squared. And in the second two terms, I could pull out a -1. And so if I want to factor this by grouping, I could write down 25x squared. And then what will I have left? When I pull the 25 out of the 75, I'm left with 3x plus, and then when I pull out the 25x squared from the 100, I'm just left with 4. And then I'll have minus. When I pull the -1 out, I'll have 3x plus 4. And then I notice that I have a common factor here. This 3x plus 4 is in both of those factors, is a factor of both of those terms there. So I can pull the 3x plus 4 out. And then what's left over in this first term is 25x squared. And the second term is just -1. And this is going to be equal to 0. And so now I have 3x plus 4. And then I notice that the 25x squared minus 1 is a difference of squares. So I'll have 5x plus 1, 5x minus 1. And so if I solve this, I can set each of those three equal to 0 by using the rational roots, by using the zero product property. So if 3x plus 4 equals 0, that tells me that x is equal to -4/3. And if 5x plus 1 equals 0, that tells me that x is equal to -1/5. And if 5x minus 1 is equal to 0, that tells me that x is equal to +1/5. So those are my three solutions. Number 31, it says to solve the rational equation. And so when I'm looking at this, what I want to do is multiply by the least common multiple of the denominators to clear out all of the denominators. And so one thing I might notice is that the bottom of that first rational expression can factor. So I can pull out an x, and I'll have x times x minus 4. Then I'll have plus 3, and then equals 12 over x minus 4. And so if I look at the things that are occurring in the denominators in this whole rational equation, I can see that an x minus 4 is appearing in the denominator, and I can also see that an x is appearing in the denominator. So what I'm going to do is multiply through by both of those things. So I'm going to multiply through everything by x, and I'm also going to multiply through everything by x minus 4. And so when I do that, I get some things that are reducing. I can see here that x over x is just going to make a 1, and then the x minus 4 over x minus 4. So what's left in that first term is just a 48. The second term, I have a 3 times x minus 4. And in this last term, that x minus 4 over x minus 4 will go away, and I'll just be left with a 12x. And now I just have a quadratic here when I multiply this 3x in by each of these things. I have 48 minus 3x squared minus 12x equals 12x, and I can subtract that 12x over. I'll get -3x squared minus 24x plus 48 equals 0. And I can see from that I can use the quadratic equation, or maybe I can factor. Let's divide everything by -3. So 24 divided by 3 is 8, so x squared plus 8x, and then 48 divided by 3 is 16 equals 0, and so I can see this factors to x minus 4, so x is equal to 4 with multiplicity 2. So that's the solution for number 31. Oh, but that's a problem, because if x equals 4, then that means I have a 0 in the denominator. So this actually has to be thrown out. And so it looks like there's no solution to this function. So this is no solution. Okay. On number 32, I want to solve this rational equation. So let me delete some things over here so we can work on that one. So I have 4x over x minus 5 minus 1 over x plus 1 equals 3x squared plus 3 over, I'm going to go ahead and factor the bottom. I can see that it factors to x minus 5, x plus 1. So if I look at the things that are occurring in the denominators, I see an x minus 5 in some of the denominators. I see an x plus 1 in some of the denominators. So I'm just going to multiply through by both of those things to eliminate all of the denominators. So I'm going to multiply this by x plus 1 and x minus 5. I'm going to multiply this by x plus 1 and x minus 5. And I'm going to multiply this by x plus 1, x minus 5. So since I multiplied by the same thing on both sides, that was a legal move there. And so I can see some things are going to reduce. And so if I look at this first term here, I can see that I have an x minus 5 on top and on bottom. So that will reduce. So I'll have 4x times x plus 1. Minus, and then I can see that x plus 1 over x plus 1 is going to go away, so I'll have just an x minus 5 here equals, then I'll have the x plus 1 over x plus 1 is going to reduce, and the x minus 5 over x minus 5 is going to reduce, so I'm just left with 3x squared plus 3 there. And so I can multiply, distribute this 4x in here, and also distribute that negative sign, and I'll be left with 4x squared plus 4x minus x plus 5 is equal to 3x squared plus 3. So I'll move everything over to one side. 4x squared minus 3x squared is just x squared. Let's see, how many x's do I have? I have 4x minus x, so that's minus 3x. And then how many constants? I have a 5, and then I'm going to do minus 3. 5 minus 3 is negative 2. This factors. X minus 2. Ooh, no, it doesn't factor. Let's see here. X squared minus 3x. Oh, it's plus 2. Yeah, so this does factor. So I'll have x minus 1, x plus x minus 2. And so that will give us the negative 3 in the middle. And so x is equal to 1 or 2. So that was number 32. So let's move on to 33. It says solve the radical equation. It says solve the radical equation, square root of x plus 18, and then plus 2 equals x. And so I can start by subtracting the 2 from both sides. We'll get square root of x plus 18 is equal to x minus 2, and then I'm going to square both sides. So x plus 18 is equal to x minus 2 quantity squared. And if I square that, I'll get x squared minus 4x plus 4. And then I can move everything over to one side. 4 minus 18 is negative 14. So x squared minus 5x minus 14. Okay, and let's see here. I want to get, I think this will factor. So I'll get 0 equals, let's see, I think 7 and 5 are going to work for me. 2 and 7 are going to work for me. 2 and 7. So if I do minus 7 plus 2, that gets it. So x is equal to negative 2, positive 7 are my two solutions. So the next question is asking to solve another radical equation. And so for this one, I'm going to solve square root of 2 times square root of 4x minus 3 plus 7 equals 9. And so I'm going to subtract the 7 from both sides and divide by 2. So when I subtract the 7, I'll get a 2 on that side, and then divided by 2 is 1. So square root of 4x minus 3 equals 1. Then you can square both sides. 4x minus 3 equals 1 squared, which is 1. Then I can add the 3. So I get x equals 1 as my solution. Okay, so the next one, I'm going to solve the equation 3 times x plus 2 to the 5/6 is equal to 21. And so what I want to do there is first start by dividing by 3. So if I do 21 divided by 3, that's 7. Then I'm going to take both sides to the power 6/5. And in doing that, when I multiply the 5/6 power times the 6/5 power, I get x plus 2 to the first. So that's just x plus 2 over here. And I have 7 to the 6/5. And then I could subtract 2. So 2. 7 to the 6/5 minus 2. And that's unlikely to be a whole number, so we can just leave it. So for the next one, it asks to solve by making an appropriate substitution. And so when I'm looking at this function here, I am seeing the same expression appear multiple times. I'm seeing this 2 plus 3 over x that appears a couple of times. So I'm going to call that thing, I'll use another variable for that. So let's say t equals 2 plus 3 over x. So then if I do that substitution, I'll get t squared minus t, and I'll go ahead and subtract that 12. Minus 12 equals 0. And if I factor that, I'll get t minus 4t plus 3. So t is equal to 4 or negative 3. And so now I'm going to go plug those two back into my original function. So I'll get 4 is equal to 2 plus 3 over x, or I can get negative 3 is equal to 2 plus 3 over x. And so I can solve these two independently of each other. So if I solve this one, I can subtract 2 from both sides, multiply both sides by x, and divide by 2. To solve the other one, I can subtract 2 from both sides, multiply both sides by x, and divide by negative 5. So those are my two solutions to problem 36. For the next problem, we're going to solve again by making the appropriate substitution. And so what I see here is I see a square root of x, and then I see a plane x. And so what we might think of that plane x as that x is equal to the square root of x squared. And so the substitution that I'm going to do is I'm going to do the substitution t is equal to square root of x. And so I'll have 3t squared minus 13t minus 10 equals 0. And I can solve that by using the quadratic equation. T equals positive 13 plus or minus the square root of 13 squared minus 4 times 3 times negative 10 all over 2 times 3. So what's underneath that square root? 13 squared plus 4 times 3 times 10, 289. Is that a perfect square? It is. So I'll have t is equal to 13 plus or minus 17 over 6. And so 13 plus 17 is 30 over 6 is 5. And then if I use the minus, I get negative 2/3. And so both of those are going to be equal to t. So I can plug that back into this original thing to solve for x. So I get that 5 is equal to square root of x, or negative 2/3 is equal to square root of x. And so I can square both sides. I get 25 equals x. And then this one doesn't give me a real solution here, because if I, well, hang on. So if I square both sides, I'll get 4/9 equals x. But if I square root them, I feel like this is not giving me a solution here. So for the next one, I get this, I want to write this solution set in interval notation. So I have negative 3 is less than or equal to negative 4/3 x plus 1. And so I can add the 4/3 over and add the 3 over. So I get 4/3 x is less than or equal to 1 plus 3, which is 4. Then I can multiply both sides by 3. So I get 4x is less than or equal to 12. And then I can divide both sides by 4. I get x is less than or equal to 3. And so if I graph that on a number line, I have 3, and I want to say everything less than or equal to 3. So that's this way is what I'm shading. And so in interval notation, that would be negative infinity to 3, and I'm going to do a bracket there. So there's the graph of it, and there is the solution written in interval notation. Okay, so if the set A is the set of all x such that x is less than 9, and the set of all b, so I'll put in negative 1 and I'll put in 9 here. So the set A, I'll draw in red. The set of all x such that x is strictly less than 9, so that's this set in red. The set B, I'll draw in green. This is the set of all x such that x is greater than or equal to negative 1. So greater than or equal to negative 1, so that goes this way. And if I want to do A union B, that's everything that's either less than 9 or greater than or equal to negative 1. So I'm combining these sets together. I just throwing everything in together. That would be all of the real numbers would be satisfied in one of those sets or the other. And so this is the real numbers, so I can put negative infinity to infinity. But if I want to intersect the two sets, I want to say everything that's in both sets. So what numbers are in both sets? Well, I'm looking for where the red and green lines are both on there. And so what I have is negative 1 to 9 with the open parentheses. Number 40 says to solve the compound inequality and write the solution set in interval notation and graph the solution set. So so here I have x plus 1 is less than or equal to 6. So that is x is less than or equal to, when I subtract 1 from both sides, that would be 5. And if I want or 1/3 x is less than negative 2, I can multiply both sides by 3, and I get x is less than 3. And so if I want to graph that, and this is an or here, so it could be that set or that set. So we're going to throw the two sets together. So I'll graph this set here in red. And so I have 5, and I want everything that's less than or equal to 5. So that's this way. And then this other set here, which I'll draw in yellow, is everything that's strictly less than 3. So it's an open circle, strictly less than 3. So what you might notice is I want to do everything that's in either set. So that's going to be, so I noticed that x less than 3 is already contained in the set x less than or equal to 5. So the solution set here is going to be, so there's the graph. The graph is going to be of the combination of those two is going to be just this graph, which is just negative infinity to 5 with a closed bracket. So the next one is asking for this one that has an and, so it means it has to be contained in both sets. And so what I want to do is first I'll just graph x minus 6 greater than 1, and I can add that 6 over, I'll get x is greater than 7. And then the other set I can get is 3/4 x is greater than or equal to 6. I can multiply by 4 and divide by 3, and I get x is greater than or equal to 8. And so if I plot these here, x is greater than 7 is going to be everything strictly greater than 7. And then x is greater than or equal to 8. That would be closed dot here on 8 and everything greater than or equal to 8. And so since it's an and here, it means it has to be in both sets. So what things are in both sets? Well, it's just going to be starting at 8, closed circle, to infinity. Those numbers are contained in both sets. So the solution set is 8 comma infinity with a bracket on the 8. The next one says to solve this double inequality and write the solution set. And so what I'm going to do is I'm going to add 9 to everything, or subtract 9 from everything. So negative 6 minus 9 is negative 15 is less than or equal to negative 3x is less than negative 9. And then I'm going to multiply everything, or divide everything through by the negative 3. And when I divide by that negative 3, all the signs are going to flip. So when I divide through by that negative 3, I'll have a positive 5 and the x in the middle. And then I'll have a positive 3. So in other words, 3 is less than x is less than or equal to 5, if I want to write it that way. So if I want to graph that solution set, I'm going from 3 to 5, and the x's are going to be everything in between. I'm including the 5, but I'm not including the 3. So here's our graph of our set, and so we're going to do an open parentheses there at the 3, and we're going to do a closed bracket at the 5. All right, next one. I have here Nancy is going to go on vacation to Austin, Texas. Great choice, Nancy. Hotel A is charging $179 per night with a 14% nightly room tax and free parking. Hotel B is charging $169 per night with a 18% nightly room tax plus a one-time $40 parking fee. So the question is, after how many nights will Hotel B be less expensive? So what we're looking for is, we don't know how many nights she's going to stay there. So let's let n be the number of nights that Nancy is going to stay there. So the cost of Hotel A is going to be equal to $179 per night plus a 14% nightly room tax. So 14% of that, 0.14 times 179, and that's each night again. The cost of Hotel B, which we can simplify that down. So 179 plus, it's going to be 204.06 in. So that's the cost of Hotel A. The cost of Hotel B is going to be equal to $169 plus an 18% nightly room tax, so 0.18 times 169 in, plus the $40 parking fee. And so we can simplify this down to be $199.42 plus the $40 parking fee. So that's the cost of Hotel B. Okay. And I want the number, oh, sorry, that's an N there. And so what I want is the cost of Hotel B to be cheaper than the cost of Hotel A. Or in other words, I want the cost of Hotel B, which is the 199.42 N, plus 40, to be less than the 204.06 N. And so I can solve for N here in this inequality. So I can subtract the 199.42 N from both sides. And I get 40 is less than positive $4.64 times N. And then I can divide by that, divided by 4.64, and I get 8.62 is less than N. So if N is greater than 8.62, or in other words, if N is greater than 9/9, so we want 9/9. So on the 8th night, Hotel A will still be cheaper, but on the 9th night, Hotel B will be cheaper. So it takes 9 nights to make up for that $40 parking fee is what we're saying here. The next one, I want to solve this inequality. And so we'll go over here and solve that dude. So we have 4 times 2x plus 7, and absolute value plus 2 is equal to 22. So I'm going to go ahead and subtract the 2 from both sides and divide by 4. So I get 2x plus 7 in absolute value is equal to 22 minus 2 is 20, divided by 4 is 5. So what this is telling me is that either 2x plus 7 is equal to 5 or 2x plus 7 is equal to negative 5. So I can have either of these two cases. So if 2x plus 7 is equal to 5, I can subtract the 7 over. 2x is equal to negative 2, so x is negative 1. And if 2x plus 7 is equal to negative 5, when I subtract that negative 7, or that 7 over, I get 2x is equal to negative 12. Divide by 2, I get x is equal to negative 6. So those are the two solutions on that one.